I didn't clear the board after the last one, but we got arc length and central angle measure. Okay, so a circle has a radius of 11 feet. So let's just draw a quick sketch. Okay, here's a circle. Here's a radius of 11 feet. Find the radian measure of the central angle theta that intercepts an arc of length 9 feet. Okay, so when I think about an angle, I usually try to just keep it consistent. We usually start with the initial side and we go to a terminal side, okay? So if we've got some sort of circle with a radius of 11 feet, that means it's 11 feet from here to here, right? It's 11 feet from here to here. And an arc length of 9 feet, you don't have to get it perfect, but you can just draw a little estimate of what 9 feet might look like. Okay, maybe that's an arc length of 9 feet. So we're supposed to find theta in radians, okay? So we can use this nifty-difty little formula. S equals R times theta, okay? Where S is the arc length, which we have, right? R is the, I want lowercase r. R is the radius of the circle, and theta is the angle in radians. Okay, so this formula helps you evaluate arc lengths. Right now we have an arc length of 9, so I'm going to put 9 in for S in my formula. I've got a radius of the circle is 11, so this is 11 here. And now I've got a little formula I can solve for theta. To get rid of 11, just divide both sides by 11. So you get 9 over 11 is theta. Just remember, in case they throw degrees at you, they want it to the nearest tenth. So with my calculator, 9 over 11, oh, no, that was 9 over 12. 9 over 11 is 0.82. So 0.8 to the nearest tenth. Okay, so that's how you do. It's nice and easy when you're given radians, but if they give you degrees, you just got to make sure to convert from degrees to radians. Okay, whoops, that's not the right topic. Okay, like this one, they give it to us in degrees. Let me do that one for you. Okay, a circle has a radius of 20 inches. So I'm going to draw my angle over this way because it's 113 degrees. Starting from the initial side, there's 90, there's roughly 133 degrees, okay? So we're supposed to find this arc length, how long it is in this circle. Remember the rule with the formula I just gave, though. S equals R times theta. Theta has to be in radians. 133 needs to be converted from degrees to radians. So we multiply it by 2 pi, divide by 360, because this is a circumference in radians. This is the circumference in degrees. So you're multiplying it by 1. So the degrees cross cancel. That's why I had 360 on bottom. So this is 266 pi over, did I do that right? Yeah, over 360. That's our angle. That's 133 degrees in radians. So now that we have it in radians, now we can plug things in to find out what S is, what the arc length is. Just the rest of this, since they want it as a decimal to the nearest tenth, the rest of this is just plugging it in your calculator carefully, okay? So my calculator, I'm going to do 20 times 266 times pi, just a rough approximation, and then divide by 360. So 46.4.